Lesson number 67 has a title of Review of Equivalent Equations and Elimination. And our first question asked us to solve by using the elimination method. So we've got two equations here, x plus 2y is equal to 8 and 5x minus 2y is equal to 4. And when we're asked to solve by using the elimination method, our final goal is to know what x is equal to and what y is equal to in order to make both of these equations true. Now x will be the same for both our first equation and our second equation, and y will be the same for both our first and our second equation. Now the elimination method is a very nice method, and it's one that you should practice a lot because it's much quicker to solve on occasion than using substitution. The way that we use the elimination method is to add our two equations together. So what we're going to do when we add our two equations together is we're going to look to see if we can eliminate a variable by doing that. And here we can right away. Because if we say 2y minus 2y, well that's 0y. And we've eliminated the y variable. Then we have to say x plus 5x, that's 6x. So we get 6x plus 0y is going to be equal to 8 plus 4. That's 12. So we can rewrite and we can say 6x is equal to 12. Because we don't have to write 0 times y, because that's just 0. And we know that 6 times 2 is 12, so x must be equal to 2. So we've got our first answer. X is equal to 2. We need to get our second answer now. We need to figure out what y is. Now here we know x plus 2y is equal to 8. So if x is 2, we can substitute that in, and we can say 2 plus 2y is equal to 8. And we know how to solve this type of two-step equation. We're going to subtract 2 from both sides. We'll get 2y is equal to 8 minus 2, that's 6. So y must be equal to 3, because 6 divided by 2 is 3. So we've got our second answer. Y must be equal to 3. We could box this, and this is one way to report our answer. The other way would be as a coordinate pair, 2, 3 in parentheses, and that would also be correct. Now we can check our work here. Let's go ahead and check our work. If you need more time with this, please pause now. The way that we're going to check our work with this problem is to substitute our values back into our original equations, and they should both be true. So if x is 2, so we're going to get 2 plus 2 times our y value, and y is 3. That should be equal to 8. 2 plus 6, well 2 plus 6, that's definitely equal to 8, so our first equation checks out. We also need to have our second equation check out to make sure our answer is correct. So if we get 5 times our x value of 2 minus 2 times our y value of 3, does that equal 4? Well, that's what we need to know. 5 times 2 is 10, 2 times 3 is 6, so 10 minus 6, that's definitely equal to 4. That checks, so this one checks. We got our answer right. We can move on to the next question. We want to solve again by using the elimination method. And in this time, if we look at it, when we add, nothing happens right away because we're not able to eliminate any of the variables because they don't add to 0. So what we need to do in this problem is we need to multiply one of our equations by a factor in order to make it so it can eliminate a variable. And here I'd like to eliminate the y's because we have a negative y and a positive 4y. And in order to eliminate the y's, I'm going to take this top equation and I'm going to multiply the whole thing by 4. Because that's going to give me a negative 4y. And then I can eliminate. So when we do that, we have to rewrite. And we're going to get 4 times 2x. That's 8x. Minus 4 times y. That's 4 times y. Is going to be equal to 13 times 4. And 13 times 4, well, that must be 52. Then we're going to rewrite our second equation, 3x plus 4y is equal to 3. Now can you see how we're going to eliminate the y's? We're going to eliminate them by adding the two equations together. So 8x plus 3x is 11x. Then we have plus 0y, so we don't need to write that because these cancel. They're equal to 0. So 11x is going to be equal to 52 plus 3, that's 55. So in this problem, 11 times x is 55, x must be equal to 5, because 11 times 5 is 55. There's our first answer. Let's find our second answer. We need to find y. So it looks like the easiest y to find will be with the smallest numbers. So we can say 2 times 5, because that's our x value, minus y is equal to 13. Well, 2 times 5 is 10. 10 minus y equals 13. We'll subtract 10 from both sides. We're going to get negative y is equal to 13 minus 10, that's 3. So if negative y is 3, well, then y is going to be the opposite. Y is equal to negative 3. We've got our second answer. Y is equal to negative 3. We can report them like this, or we could report them as a coordinate pair, 5 comma negative 3. We're all done, and we can move on to the next question. This answer is correct, and you could check it if you like to make sure that it is correct. We've got one more today. We've got to solve by using the elimination method again. And this time when we look at it, well, there's no one thing that we could multiply through our top equation or our bottom equation in order to eliminate a variable. So in this one, what I see is 2 positives here, and I see 1 positive and 1 negative. So we've got a choice of what we want to multiply. I'm going to take the top equation, and I'm going to multiply it by 4. And I'm going to take the bottom equation, and I'm going to multiply it by 5. That way, we're able to get to positive 20y and negative 20y, so the y's eliminate. We could have also multiplied by something to eliminate the x's. Maybe we would have multiplied by negative 3 and positive 2. Both ways work. So we're going to get the answer 4 times 2x, that's 8x. 4 times 5y is going to give us plus 20y. Is going to be equal to 4 times negative 7, that's negative 28. Then we get 5 times 3x, that's 15x. 5 times negative 4y, that's going to be negative 20y. And see, that's exactly what we wanted, because this is going to eliminate. It's going to be equal to 5 times 1, which is 5. And now we can go ahead and solve. 8x plus 15x, because when we eliminate, we add the equations together. Give us 23x. 20y minus 20y, that's 0, so that cancels, it's equal to nothing, is going to be equal to negative 28 plus 5, that's negative 23. Oh wow, this one worked out well. X must be equal to negative 1, because 23 times negative 1 is negative 23. Now we've got to solve for y. Let's use the second equation this time. So if we use the second equation, we can go ahead and erase what we multiplied by so we can see the original. And we're going to get 3 times our x value of negative 1 minus 4 times y is equal to 1. You can substitute your x value into the first equation or the second equation, whichever you prefer. 3 times negative 1 is negative 3, minus 4y is going to equal positive 1 here. So we're going to add 3 to both sides because we're trying to isolate the y variable. We're going to get negative 4y is going to be equal to 1 plus 3. That's 4. So y must also be equal to negative 1, because negative 4 times negative 1 is positive 4. So we've got our second answer. X is equal to negative 1, y is equal to negative 1. We could also report it as an x-y coordinate pair, and if we were to do that, we would get an answer of negative 1 for x, negative 1 for y. And we'd box this, and we're all done. Key with elimination is to pick the variable you're going to eliminate. Sometimes you may have to multiply one equation or both equations in order to do that, and then you can solve by adding the 2 equations together and finding the value of your x or your y. Lesson practice will be on page 274. Make sure you've got your notes complete, and I'll see you during our next class.